Hello everyone, welcome back to my YouTube channel. In this lecture, I will be discussing about process scheduling. That is one of the most important topic of operating system. Fine. Before starting up the sessions, I would like to request you please shares and subscribe my channel. Okay. For more informations, you need to click on the bell icon so you will get the latest notifications. Okay. This video is very much important to all of the students who are preparing for their university exams, whether they are preparing for the competitive exams or any of the students who are preparing for their upcoming examinations. This video will be very much helpful for them. As we know that in operating system we have multiple types of functionalities. Operating systems do memory management, operating system do various kinds of operations like process management. Among these process management we have process scheduling. So what is process scheduling? Why we require process scheduling? So you need to understand that. So you have to also understand this one. This topic is very much important for your exam perspective. Maximum number of questions could be asked from these sections. Okay. You cannot escape this topic as its topic has very much importance. Okay, for your exam. Let's begin with the core concept of process scheduling. Why we required it basically. You know, in computer system, we have the heart of the system as operating system. We consider operating system as a heart of the system. Why we consider it? Because operating system manages the entire things. It gives the platform, it manages the entire systems basically. Among that functionality, we have one of the functions, that is process scheduling. Let's have an example. When you turn on the system, then it means that multiple applications is there in your systems that is residing in the secondary memory. That means it is a new state, but you are not opening every application. Each application is not being opened when you turn on the systems. Okay, some of the application turned on, but some of the application resided in the secondary memory. When you bring those processes from new state, that means the secondary memory, to main memory, that means ready states, as you have seen that new one, ready another, and the running another, then the termination, this is the another, and this is the waiting. This was the scenario we have already discussed in our previous video. Fine. So when we have P1, P2, P3, these are residing in the secondary memory. When it reaches to this ready state, that means main memory is there. From main memory, one by one, that means unit process will be goes to running state. That means CPU is there. CPU control will assign to P1 one process at a time. That is called the unit processing system. When single processor is there, if there is a multiple processor, so then the capability of processing will be maximized. That means multiple process can be executing at one unit time. Fine. That is the concept of multi-processing system. So we'll talk about the single processing system. That means one process at a time will be getting the control of the CPU. When the CPU control given to the P1, then means P1 is executing. So in that manner, some high priority process came. That means there is a residing P1, P2, P1 is already moved there. High priority process came and P1 has to interrupt. P1 has to stop. So P1 not completing its entire unit time, its entire execution, but in the middle, P1 has to release the control of the CPU. What it does, the operating system will be there to manage such things, to schedule the other process which has the high priority. So operating system involved here. What operating system do? Operating systems instruct the CPU release this process P1 and take this process, that means P2, releasing P1 and taking back P2, a new high priority process. In this way, multiple number of process can be shifted from ready to running state for a system to run efficiently. Fine. If it is not so in the system, then we can consider CPU will be in idle time. It will not give the proper efficient use of the system. Fine. That means if any input or output operation happened, IO, that means IO, you are that means you have you have a printer, you want to get the print, or you have any other peripheral devices you want to connect like mic or anything else, then input output operation will be there. So what it means, there is also some time, some time vested in this position, in this area, in this situation, IO operation. So what it does, in this time also CPU take another process to execute it. CPU will not be in idle time. Fine, that is the concept. Here, why we are talking about process scheduling? Because of its efficient. Because the major objective of process scheduling to get the maximum utilization of the CPU. As per the definition based, you can understand it is the mechanism by which the operating system decide which process will use the CPU next and for how long the CPU control will be assigned to that process. The duration is also managed by the operating system. How long control should be given to a specific process, that is one of objective. Which process will get the control, that will be decided by the system, that will decide by the operating systems. In operating system we have CPU. Okay, durations and which process will get the control, these things will be done in process scheduling. Fine. And also it maximizes the utilization of the CPU. Maximum utilizations. Like in manufacturing unit, we have machines. We always try to get the maximum use of that machine to produce maximum number of products. We cannot make the machine in idle times. We must ensure that the machines are working continuously and giving maximum number of products. So in the same order, we have the laptops or the any mobile phone or any other such devices through which we can expect that maximum utilization can be performed. I'm giving you a real life examples, like when we serve our mobile phones, we can at the same time we can go to the browser also, we can book the ticket also, we can use the WhatsApp also. At the same time, multiple applications is open, you are working on that applications, and in between there is a switching of the process. How the switching of the process happened, that is done by the operating systems in the term of process scheduling. Fine. Okay, so we have two types, we have multiple types of operating system, but the two things you need to understand: what is multi-programming operating system. In multi-programming operating system, we have the concept like our objective is like to maximize the utilization of the process. We are unaware about how the process is switching in between behind the screen, but the objective is very clear that like maximizing the utilization of the CPU in multi-programming environment. Fine, multiple programs are keeping in the memory, and from memory it is getting the control of the CPU. Okay, without wasting any time, CPU does the execution. Fine. Okay, so this is multi-programming. Next one is multitasking. Multitasking is for the user perspective. So multitasking types of operating system does the user perspective, means user think that the response time is very good and efficient response, it is giving a proper response, user interface is very good. Okay, so that is the kind of things in multitasking. Multiple tasks can be performed and you cannot have idea that how it is performing behind the scene, but it does. So main objective of multitasking to give the user experience, better user experience, responsiveness, and so on. Now moving to the right, how the process scheduling give you the multiple techniques, okay, various techniques to handle such kind of things, such kinds of issues when the CPU try to execute the programs. See, we have first type of algorithm, that is FCFS. Second types of algorithms we have SJF. Third time algorithms we have SRTF. And fourth type we have priority scheduling. Fifth one we have round robin scheduling. Sixth one we have multi level feedback queue. Fine. So these are the important, which we can say it's a core approach, core part of the process scheduling algorithms. Okay, very important algorithms we have. Among them, always the question asked from this section. Sometimes this is not keeping so much importance in your examinations, like you if you are preparing for your university exams, for GATE, NET, or any state level examination where the computer science paper is there. Okay, so among them all are important. So these are the scheduling algorithms. Scheduling algorithms. Fine. So here in scheduling algorithms, we have also categorized there. One is preemptive, another as non-preemptive scheduling algorithm. This is very much important for your exam perspective. One is preemptive, another is non-preemptive. What do you mean by preemptive? You need to understand what is preemptive scheduling algorithm. Preemptive means what? When a CPU control is given to a process P1, so preemption means what? If any other high priority process came and asking the control of the CPU, then say operating system will decide whether it should be given to that high urgency process or not. So that will be decision made by the operating system. If the decision make that yes, the high priority process will get the control of the CPU, while ongoing process P1 has to stop, there is a called a preemption. Preemption means what? By interrupting in between the ongoing process, the CPU control switches to another high priority process. That is the concept of preemption without completing its the entire unit time. That is the concept of preemption or preemptive algorithm, we can say. So that means when the preemption happened, then the utilization of the CPU will be maximized. Efficiently, it can be worked. Fine. So this is the main important things we have to keep in our mind. Preemptions. There is an interruption. When the interruption happened, then we can say preemptions happened. So no preemption means this is another one. No preemption is opposite to preemption. No preemption means it does not allow. It does not allow any preemptions or any interruptions. If the CPU control is given to process P1, then none of the other process which has the high priority or low priority or any types of scenario based on any kinds of urgency, it cannot be switched at any moment. Once the CPU control assigned to a specific process, then that process must complete its entire execution without getting hampered its ongoing execution. Fine. So this is the main points you need to remember about the preemption as well as non-preemption. So preemption is very much important, and some algorithms behave as a preemptive mode. Okay, so based on preemptions, we have various types of algorithms. You can see we have SRTF, that is based on preemption, priority preemptions, round robin preemption, multi-level preemptions, except FCFS and SGF. FCFS, that means first come first serve basis algorithm, and the another one is shortest job first. These two algorithms based on non-preemption mode. So that means once the process get the control of the CPU, it will never give the control to any other process until or unless it finish its execution. That's it. Okay, so these are the 6 important algorithms of process scheduling, that is called scheduling algorithms, and these scheduling algorithms follow preemptions, or that is the preemptive, non-preemptive, preemption and the non-preemption preemption manners. Okay, now you can see these 6 algorithms will decide how the system could be efficient. Which algorithms has the maximum turnaround times, maximum or minimum turnaround time, maximum waiting time, minimum waiting times. So you have to calculate those things. You can expect some theoretical questions from this section, but maximum questions will be asked in the form of numericals. So maximum numericals you may expect from such sections, that is process scheduling algorithms. In your numericals, they will ask about various things like turnaround time. What is turnaround time? What is waiting time? Okay, before understanding this one, I can make you understand this one. This is the scheduling criteria. We can say scheduling criteria. This is called scheduling criteria. So what are the scheduling criteria? First one is arrival time. Arrival time. Second one is burst time. Third one is turnaround time. Fourth one we have waiting time. Fifth one we have response time. These are the important scheduling criteria. From these sections, you have to answer based on this scheduling algorithms. In based on FCFS, either based on SJF or any such algorithms in your question in your exams, they always ask from this scheduling criteria. If the arrival time, that means process arrived in the ready queue. Process arrive in the ready queue. For for doing such solutions based on various algorithms, you have to draw the Gantt chart. Gantt chart is very important to deal with the numericals. Fine. Arrival time, when the process arrive, let's assume P1 arrive at 0 time, and burst time, that means this is the arrival time when it is in ready state, when the process in ready state arrived in ready state. Burst time means total time it required to execute. A process required 10 unit time for its complete execution. Another process required 5 unit time to complete execution. That is called the burst time. Burst time is the total time for any specific process to be in the CPU. Okay, to get the control of the CPU and from the beginning to the end. Once it's assigned the CPU control, and throughout its executions, when it finishes its burst time, then we can consider the process has been completed its execution. So that means burst time is what? It is the total time any process required to its execution. Let us say P1 required 5 unit time, it will continue for 5 unit time. Turnaround time means what? Next process came at P2 at 5. So that means another process which is P2 which came at 5 and completed at 10. So that means what? Total that is called turnaround time. Turnaround time is completion time minus that is the formula, completion time minus arrival time. This is the formula for turnaround time. You can get the turnaround time for P2. P2 came as 5 and completed at 10. So you can see P2 came at 5 and completed at 10, 10 minus 5. Waiting time, that means waiting time formula will be turnaround time. You got the turnaround time and minus burst time. This is the formula for waiting time. Response time, how the quick response given by the processor. So this is all about the process scheduling concept. The core concept, the fundamental ideas about the process scheduling, how the systems perform, okay, that totally depend on the various algorithms. Which algorithms is in use, that is decided by the operating system. Okay, so all these things managed by the operating system, which has the responsibility to manage all the things, all the types of tasks inside the system and give the maximum utilizations of the CPU and make the system perform well. And we can consider also, if there is a maximum and maximum utilization of the CPU is there, multiple numbers of process get the control, okay, they are busy with this CPU, then there is a chances of lagging, or there is a chances of some delay. You may also, somehow it is acceptable balanced one. When it is in a balanced situation, the system will perform well. When you give more load on your processing, means you have opened multiple applications and you're working on multiple applications, there's a chances of lagging because your processor capability is not that much which you are expecting. Okay, that's the reason you face lagging in your system. So this topic is very much important for your exams. Multiple types of question you may expect. Okay, so you have to practice more and more numerical. For such numerical sessions, I will be uploading in next videos. Okay, so you can get the idea about the numericals problem based on process schedulings. We'll start from FCFS and we'll end up with multi-level feedback loop. All the 6 types of algorithms based numericals will be covered in my upcoming videos. So try to watch these sessions clearly without skipping this video. Try to understand the core concept of process scheduling. So this will help you out to score more in your semester exams or in the competitive exams. Hope you have liked this video. So I'm requesting you again, like, share and subscribe my channel for more informative videos, for more informative information regarding the career and the educational support. So hope you have understood properly. Wish you well. Thank you. Bye bye. Take care.